All right, Algebra 2, here we go, moving into Chapter 6, Roots and Radical Expressions. Okay, a lot of this should look semi-familiar to you. Our essential today is what is the nth root of a number. You've done a lot with square roots. We're going to look at more radical stuff with finding the cube roots and the fourth roots. More cube roots than anything. Fourth and fifth roots of numbers that we're familiar with. To kind of refresh your memory here, when you've got the square root of a number to the nth power, okay, whatever exponent you're trying to find the root of, well, that's called the index. That's our radical sign. That's the radicand. Can't say that you're going to see this anymore, but you will hear me talk about the radical sign a lot, and that's what I mean right there, that symbol there. The nth root, a to the nth equals b, where n is a positive integer. If n is odd, you'll get one root, okay, no plus or minus. If it's even, though, that's where the plus or minus comes in. That's what we've been doing, taking square roots of numbers, and we get plus or minus when you're solving for x. Okay, some examples of finding cube roots, and you got to put your thinking cap on here, okay? What times what gives me 1,000? 10 is. So 10 is the cube root, or the third root of 1,000. Now, because it's an odd root, you can also take the power of negative numbers now. Okay, if that's an odd root, you can take that root of the negative numbers. So negative 10 would be the cube root of negative 1,000, because negative 10 times negative 10 is 100, times negative 10, negative 1,000. Okay? Don't be confused here. The cube root, when you're looking at some of these decimals, okay, the cube root of 8 is 2, but the cube root of 0.008 is 0.2. Because remember, when you multiply decimals, you keep moving the decimal point over. So when you take 0.2 times 0.2 times 0.2, there's your 2 times 2 times 2 is 8, but you got 1, 2, 3 places to move the decimal. So you get those 2 zeros in there. Okay? So don't let that confuse you. The fourth root here, again, it's a negative number with an even root. You can't do it because the negative's inside. If you're taking roots of fractions, it's like taking the root of the top and the bottom. In this case, they're both perfect fourth roots, because 2 times 2 times 2 times 2 is 16, and 3 times 3 times 3 times 3 is 81. So plus or minus 2/3 would be the root there. More over here. I didn't mean the negative root there. The cube root of negative 8 is negative 2, same reason as over here. The square root 0.4, same thing we talked about here. It's 0.2, because 0.2 times 0.2 is 4, but move the decimal point 2 places and you get 0.04. You can't take the even root of a negative and square what's inside first. Negative 2 squared is 4, the square root of 4 is 2. So in that case, we're good. Simplifying here, you can take the square root of 16, it's 4. And remember now, when we talk about square rooting or taking the root of something raised to the power, okay, it's just that power divided by whatever the root is. So here it would be, think 8 divided by 2 is 4, so you get x to the fourth. 6 divided by 3 is 2. 9 divided by 3, you get 3, so it's a squared b cubed. Okay, that's where that comes from. All right, whatever the root is divided into there. If it doesn't go in evenly, then you got to split it up, and that's what's going to happen next here. Okay, when we get to the next chapter. But that's what we're looking at here right now. In 6.1 and 6.2 we'll expand on this, simplify some more, and multiply and divide. Okay, but for right now we're just going to simplify these here, get our mind kind of in the right frame here of thinking about cube roots, and we'll move on from there, look at some application on it tomorrow. Alright, see you then, bye.